The discovery that should not exist. There are discoveries that merely expand astronomy. Findings that quietly add another data point. Another catalog entry. Another footnote buried deep inside a technical paper. Then there are discoveries that confuse astronomers. Findings that force revisions. Debates. Cautious adjustments to long-standing models. And then there are discoveries that crack open the very floor beneath physics itself. The kind that stop conversations mid-sentence. The kind that make Nobel Prize winners pause during interviews. The kind that make cosmologists stare at glowing screens in silence. And whisper, almost afraid to say it aloud, "This doesn't make sense." Discoveries that don't merely challenge theories. They threaten to dismantle them. The James Webb Space Telescope has just delivered that kind of discovery. Webb looked deeper than any instrument in human history. Deeper than Hubble. Deeper than anything ever built by human hands. It peered beyond the cosmic dark ages. Beyond the veil where light was first allowed to travel freely. Into a time when the universe was supposed to be simple. Young. Unformed. According to everything we believed, this era should contain faint, chaotic, half-assembled protogalaxies. Loose clouds of hydrogen. Barely beginning to collapse under gravity. Slowly learning how to become galaxies. Instead, Webb found monsters. Hyper-bright. Compact. Densely packed with stars. Objects that should not exist for another billion years. They are not forming like galaxies. They are not evolving like galaxies. And in some cases, they may not be galaxies at all. As the images arrived one after another, each breaking a different pillar of cosmology, a realization spread quietly through the scientific community. James Webb didn't simply reveal new objects. It exposed deep fractures in our understanding of the universe. It started with what appeared completely unremarkable. A small yellowish blur buried in a deep field image. Barely distinguishable from thousands of other faint points of light. There was no reason to focus on it. No dramatic flare. No obvious structure. Except for one detail that refused to go away. It was too bright. Not slightly brighter than expected. Not marginally off. Catastrophically brighter. Bright in a way that violated every luminosity model for the early universe. At first, astronomers assumed the simplest explanation. It must be closer than it appeared. A common illusion in deep space observation. Distance can lie. Light can deceive. But spectroscopy destroyed that explanation almost instantly. The redshift was enormous. The distance was real. There was no mistake. They were observing an object that existed when the universe was only about 290 million years old. The problem was immediate. It didn't look young. It didn't look small. It didn't look chaotic. It didn't look primitive. It looked massive. Structured. Mature. A fully grown cosmic city appearing in an era where only scattered villages should exist. That was the moment quiet panic set in. Because if even one fully formed galaxy existed that early, then our entire timeline of galaxy formation was wrong. And then Webb revealed something worse. It wasn't alone. Within days, more objects appeared. Then more. Then dozens. Then hundreds. Deep field images designed to reveal cosmic infancy. Instead revealed brightness. Organization. Unexpected complexity everywhere. Webb wasn't observing a universe learning how to build structures. It was observing a universe that already knew how. Recent studies identified dozens of candidate galaxies forming between 200 and 400 million years after the Big Bang. According to the standard lambda CDM model, this should be extraordinarily rare. Nearly impossible. One study author admitted openly. If even a fraction of these objects are real, galaxy formation theory will require major revision. Possibly from the ground up. The early universe is not behaving like a blank slate. It looks old at the edges. Too old. Too organized. As if entire chapters of cosmic history are missing. Then came something even more disturbing. In modern galaxies, only about 10% of available gas ever becomes stars. This limit is so universal it's considered a cosmic law. Radiation pressure. Stellar winds. Supernova explosions. All work together to shut star formation down. But Webb observed early objects with star formation efficiencies far beyond anything seen today. Systems converting gas into stars at breathtaking speed. With almost nothing left behind. That shouldn't be possible. Not under known physics. These objects do not behave like galaxies. They behave like something else entirely. Something we don't yet have a name for. Some researchers now cautiously suggest these may represent an unknown early class of cosmic structure. One that predates all existing formation models. And that idea is deeply unsettling. Because it suggests we are not missing details. We are missing an entire phase of cosmic evolution. Then comes the expansion problem. For nearly a century, we've understood that distant galaxies recede because space itself is expanding. Beyond a certain distance, objects recede so rapidly that their light should be nearly unreachable. Yet Webb sees galaxies at distances and epochs that stretch this framework to its limits. Yes, the observable horizon grows over time. But Webb's observations push that explanation dangerously close to collapse. We are seeing objects that appear too distant. Too early. Too mature. To fit comfortably into any single cosmic timeline. The observable universe spans about 92 billion light-years. Not because the universe ends there. But because light beyond that boundary hasn't had time to reach us. Yet Webb is showing structure near this edge. That looks astonishingly developed. Which raises an uncomfortable question. What if the early universe was never featureless? What if structure existed before we thought it could? The Big Bang model states the universe entered a hot, dense phase 13.8 billion years ago. But if galaxies appear mature just a few hundred million years later, then the transition from chaos to structure was either unbelievably fast or fundamentally misunderstood. A small number of physicists are now exploring radical ideas. Not claims. Not conclusions. But possibilities. That the Big Bang may not mark an absolute beginning, but a transition. A phase change. In a universe whose deeper past remains hidden from view. In this interpretation, Webb is not showing us the first galaxies. It may be showing us fossils. Remnants of a cosmic era we were never supposed to see. This is not a minor correction. This is a stress test of the entire cosmological framework. Right now, scientists do not know what these objects are. They are not galaxies as we understand them. Not quasars. Not protostars. Not clusters. They are compact, hyperluminous, star-dense systems that refuse to follow known rules. This is not an anomaly problem. This is a physics problem. After decades of confidence, cosmology is facing a quiet reckoning. Because when a telescope shows you something that should not exist, you have only two choices: change the data, or change the universe. The data is not changing. And when everything Webb has revealed is placed side by side, the brightness, the mass, the timelines, the efficiency, the maturity, a pattern becomes impossible to ignore. The early universe does not look young. It looks active, organized, awake. The problem may not be the galaxies. The problem may be the story we told about the universe. And James Webb, with its golden eyes fixed on the deepest darkness, may have just shown us that the beginning of everything is far less simple and far more mysterious than we ever dared to imagine.